Let us see the other properties, that is potential. Fourth one, potential is constant within and on the surface of a conductor. That is, we have been discussing about the electric field. Then what is the potential related to a charged conductor? We know the relation between the electric field and the potential, as electric field can be expressed as a negative gradient of potential, which is given as E is equal to minus dV by dr. But for a charged conductor, within the conductor, the electric field is 0. So this becomes, when E is equal to 0, dV by dr is equal to 0. When the gradient or the rate of change of any physical quantity is 0, that implies that that physical quantity is always a constant. So this implies that V is a constant. That is, anything which does not change under differentiation will imply that it is a constant. So electrostatic potential is a constant inside the surface, inside a conductor, and also over its surface. That is, the electric field may be 0, but its potential is never 0, but it's a constant value. Okay, next, E, the electric field on the surface of a charged conductor is proportional to the surface charge density. That comes as a direct consequence of the fact that the net charge inside a conductor is 0. Where does the charges reside? The charges resides on the surface of a conductor. So obviously the electric field should be proportional to the surface charge density by the expression E is equal to sigma by epsilon 0. For a charged conductor of any size or shape, the electric field is given by E is equal to sigma by epsilon 0, and sigma is equal to Q by delta S. We have seen this expression already in the previous chapter when we learned about Gauss's law and its application. So E is equal to sigma by epsilon 0, where sigma is known as the surface charge density, which is given by charge divided by the surface. Finally, we have the last one, the sixth property, or the electrostatics, related to the electrostatics of conductors, which is very interesting, or which has a lot of wide applications even in our daily life, also in the we can relate it to many cases. So next is the electric field inside a cavity of a charged conductor is 0. Electric field inside a cavity of a charged conductor, or cavity means it's hollow. Charged conductor is always 0. So suppose you have a hollow charged conductor, it has charges which resides on the surface of a hollow conductor. The electric field within the cavity is 0. This phenomenon is known as electrostatic shielding. It is known as electrostatic shielding. It has a wide range of applications. So it is known as electrostatic shielding. So electrostatic shielding is the phenomenon of making a space free from external electric field, or a space which is free from external electric field, even though the charged conductor, the hollow conductor, may be charged. Within the conductor, the electric field is 0. Such a cavity inside the conductor which is shielded from external electric field is called is a consequence of electrostatic shielding. So the applications of electrostatic shielding is that the most common one is that we always say that it is safer to sit inside or to be inside a car or a bus when there is strong lightning or thunder. At the time of thunderstorms, it is safer to sit inside a car or bus. The reason is that the metallic body of this of the car will act as the screen or electrostatic shield, which will protect you from the external electric field of the thunder or the lightning. Okay, so that is one important application of real life application of electrostatic shielding. Next is very sensitive instruments are protected from external field by placing it inside hollow conductors. That is, whatever external disturbance or external field may happen, certain sensitive instruments can be protected by placing it inside hollow metallic boxes or metallic shields. That is another application. In the case of coaxial cables, that is, a earthed conductor will always act as an screen to protect any interference with the external electric field. So that is also an application of electrostatic shielding. So we have completed all the six important characteristics which is related to electrostatics of conductors, be it charged or uncharged. So usually we talk about charged conductors, and we have seen gone through all the six